Good morning, and thank you for joining me early here today. For those of you in attendance already, I ask that you please hold on. We're going to give it another 3 minutes to see if anybody else is going to join in. We've got a decent crowd already, and I'm looking forward to presenting to everybody. So just sit tight. We'll start here at 11:01. Thank you very much. Okay, good morning, everybody. Thank you very much for joining in with me today. My name is Zachary Stank. I am the product manager for Control Safety and IO here at Phoenix Contact for the United States. Today, we're talking about U.S. machinery safety requirements. So I thank you all for taking time out of your afternoon or your morning to join in live with me. If you're not live and you're joining afterwards, thank you very much for taking time out of your day to come and watch the replay. If you are watching the replay, unfortunately, I won't be able to answer your questions live. But if you are live with me here right now, you can type in questions into the live event Q&A. I will try my best to answer them as I go along. Just so you know, it is a 20-second delay between when I'm talking and when it gets broadcasted to you. So if I do pass a slide you had a question on and I don't answer it directly, I will be reviewing everything at the end. So please stick around till the end and I will try my best to answer any questions that I may have missed. So I'm not intentionally skipping questions. It just is a function of the teams live here and how we work. Also, I want to thank you all for signing up through our US-webinars website, and you can find more of our webinars directly on that link. We'll be loading up our Q4 webinars here in the next week. So please check back to phoenixcontact.com/US-webinars. Probably, I'd say at the end of the month, you can see what new webinars we have coming up for the last quarter of this year. So without further ado, let's get started. So again, my name is Zachary Stank. I'm the product marketing manager for Control Safety and IO here at Phoenix Contact. My contact information is there on the screen. If you want to follow me on Twitter, I do occasionally post there. I am more active on LinkedIn now. Twitter is more of an overarching, events coming up for Phoenix Contact. But if you want to interact directly on LinkedIn, you can find me there by searching my name. I am publicly available. I've been at Phoenix Contact for the last 10 years. Before I was a manager, I was the safety guy here, so the product specialist for safety for 8 years, continuing to cover that role for now as I got promoted to the product marketing manager for Control Safety IO. I used to do a lot of our trainings for safety here. I still do some of them. I do our cabinet confidence trainings. I also do a lot of content online too, so definitely I think worth a follow. If I'm gonna, pimp myself a little bit here, go ahead and follow me on LinkedIn, Twitter, what have you, and we can interact there beyond this as well. So one thing I want to overview for everybody, if this is the first time you're joining in to a Phoenix Contact webinar, one of the things we like to talk about is our cabinet confidence. So Phoenix Contact sells many product lines, many SKUs. And to help everybody understand kind of what type of products we have, we've created this cabinet confidence or complete line overview of our products. And we broke it ourselves down into 7 major functional areas where you can find product for Phoenix Contact. And those are power reliability, connectivity, signal switching and conditioning, safety, networking, automation and control, and shop floor productivity. So at Phoenix Contact, we really try to be your trusted partner for the control cabinet, giving you all the essentials that you need, whether you're doing simple relay switching, full-blown automation control, or in the future, getting to the cloud. We really want to be your partner for success, and we have the confidence that we can do that for you. So you can see as a company, we do break out safety as its own piece here. And for a lot of people, they ask, what is safety? That's the main question I get a lot of times. And so for Phoenix Contact, I like to say safety is definitely the protection of personnel and property. It's paramount to everything that you do in safety. It's the reason you're doing safety. You're protecting your people, you're protecting your investment in your machines. And an effective design coordinates many aspects of the system's operation. So you're not just doing this to make the operator's life awful. You're really doing safety to make sure that someone can't get hurt, or that you can't destroy a product, or that you won't cause an environmental disaster or something like that. And the most important point here at the end is you have to have a risk analysis. So a lot of people come to me and say, I need to add safety to this machine. My first question back to them will almost always be, did you do a risk analysis yet? And the reason for that is you can't fix what you don't know. So you need to know what's going on. You need to make sure that you analyze all the risks, get involved with the system on the floor, and that way you can make sure that you're properly creating a safety solution for your system and you're not over designing or under designing. But a lot of people still come and they say, that's not the kind of safety I'm talking about. I'm talking about Osha. And I really want everybody to understand, yes, Osha in the United States is the #1 source for safety. It is a reason a lot of factories do safety here in the United States, and it is hanging in the back of mind of every plant manager is hopefully I'm doing things and Osha is going to come in and give me a clean bill of health. And to be honest with you, that is very much important. But it's beyond just Osha. If you get beyond that mindset of I'm protecting myself against penalty and start thinking about how can I do this to increase productivity? If I'm properly protecting my machine, I should have good uptime. I should have the flexibility within my machine to add different things or create a different product or a different cell and not really interfere with the safety of my machine. It shouldn't be something that worries me. So adaptable configurations and safety integrity are important. It goes beyond Osha, but Osha is ultimately paramount for everything we talk about here today. So I will be covering, before I jump to the next slide, I will be covering purely machine safety here in the United States. I will not be covering a lot of Canadian or other North American standards. They're very similar. If you have questions about that, we can answer those separately, or I can get in touch with you then. We will be talking a little bit about international safety and what that means and how that works. And then we'll also be talking a little bit about things you can do to make safety easier at your facility. So I'm really looking forward to some of the questions you might have, and feel free, we have a whole hour here, so feel free to stop me and ask questions when you want. So an easier way of explaining safety is, again, protecting people, products, and the environment from machine and process faults. So if something goes wrong on the machine, I want to make sure that I'm protected and that my machine is protected, my products are protected, and the environment is protected. It's always something going wrong is what we're protecting against. And the one thing that is frustrating to a lot of people is that, you know, if I get a call and I say, you know, someone says, Zach, the safety isn't working right on my machine. I don't know what's going on. I can't get it to work. And unfortunately, if the machine is off and safety is engaged, safety is working properly. So safety isn't working properly when you can't turn off the machine, or it's in a runaway condition, or it's doing something that is very hazardous. So it's kind of backwards thinking in that point, but you want to make sure that when you're thinking about safety, safety is the state of being safe, which is a terrible definition because I'm using the base word in it. But ultimately, if your machine is off, if your machine is not doing what you want it to do, but it's not, you know, it's not running, it's not out of control, ultimately safety is protecting you from something. It's either protecting you from a fault within the machine, a wiring problem, or maybe it wasn't designed properly, right? And that we call this freedom from unacceptable risk. So there's no way to be absolutely safe. Even just walking outside today, you know, it's a beautiful day here in central Pennsylvania. The sun is shining, so when I'm driving, I have to be careful that the sun doesn't get in my eyes. There's a risk that I could be in a car accident. There's a risk I could get a terrible sunburn because the sun is out. So there's many risk factors that go into everyday life. We have to think about machines the same way. You're never going to protect a machine completely from any problem that you have. But the idea is to get beyond that unacceptable risk, right? I don't want risk to be in a machine that is unacceptable. And then finally, the easiest way to think about the components of machine safety is in three parts. There's always an input, there's always some type of logic controller for safety, and then there's output. The input might be a single channel e-stop, the logic might be a single channel relay, and the output might be a contactor, right? But those three pieces all must be there. If you don't have all three, you don't have a safe piece, right? You don't have the safety functions that you need in order for something to be safe. So if I'm going right from an e-stop to an output contact, I don't have a safety system, right? Because I don't have logic. Or if I'm just going logic to an output and I'm only using, let's say I'm just using a non-safe input on there, like a push button or something like that, then even though I'm using a logic controller that's safety and my outputs might be the highest level of safety, I am not safe because my input has to be safe as well. So it's just an all-around good idea to remember that you have these three pieces, you need to have these three pieces or else you don't have it. So let's take a deep breath and think about safety standards. So in the US, this gets very confusing. It's the main reason that I see a lot of people in non-compliance with safety. But it's also very frustrating because it's not as direct as it seems. So the first thing, and the thing that I said was paramount to start with, is OSHA. So if you go to osha.gov, you can look at the standards, CFR 29, OSHA 1910 Subpart O is machinery and machine guarding. Let me bring that up on the screen here. I think I had that one pre-done. Yeah, so here's your regulation standard. That's the 29 CFR. You go down to Subpart O, you get down there, JKLMNO, machinery and guarding. So in terms of the United States, law for machine guarding is under Subpart O. So anything that is in Subpart O is law and must be followed. So they have definitions, general requirements, woodworking, cooperage, abrasive wheel, mills and calendars in the rubber and plastics industry, mechanical power presses, forging machines, and mechanical power transmission or apparatus. I know what you're all thinking right now. Zach, you just named 9 things. I have none of those 9 things in my facility. Am I free from safety? The answer is no, because even though these are the law as defined by OSHA, OSHA also has a general use clause that says that any nationally recognized standardization organization can give you a standard to follow. And even though OSHA doesn't cite it here as law, you must follow it if it's not given directly by OSHA. So what that means is that OSHA may not list what you're doing on this screen. You may not see it on here. That's okay. It just means you have to keep digging, right? And even if it was on this screen, I would say keep digging afterwards. So you go to standardization bodies like Ansi or the IEC and look at what they have for your specific machine, and then you can cover yourself. So if we go back to my slide here, you have the Subpart O, machine guarding. It's the owner's responsibility in the United States. So if I have a machine and I say, hey, I bought it from manufacturer X, manufacturer X provides it to me, OSHA comes to my facility and somebody got hurt on that machine, OSHA is going to find the owner, not manufacturer X. They will find the owner for non-compliance, right? So it's important to understand that because it's kind of backwards to everywhere else in the world. In the United States, the owner is responsible for the safety of the machine. So if you're purchasing a machine, you're putting a machine on your floor, you need to make sure it's properly guarded and it's something that you need to request from the manufacturer if that's what you're looking for. So big piece there. The owner of the machine in the United States is responsible for the safety of that machine. Then we get into, again, like I said, keep digging. If it's not in there, keep digging. So like ANSI B1119 has performance criteria for safeguarding and also has risk assessment tools that you can use. NFPA 79 is the electrical standard for industrial machinery. There's lots of information about requirements for safety in NFPA 79. I believe that was also just updated a few years ago. I know we have a NFPA 79 landing page. I'll put that in the chat after we're finished. But definitely keep digging. If you don't see something, it doesn't mean it's not covered. You need to find a nationally recognized standardization body. And then if you're looking for international type of shipping or international type of customers, you might have heard of the machinery directive or EN ISO 13849 or 62061. These are important international standards. Generally, most of the international community follows these standards, especially Europe does. I believe the UK has adopted them since Brexit to maintain this. But essentially what the machinery directive or this EC marking or the CE marking that you would see is that you're following either one of these required safety directives to ensure that the safety of your machine has been done. So if I'm shipping to Europe and I have somebody in Europe using my machine, then I am responsible for the safety of that machine until end of life. So it's different from in the United States. United States, I ship a machine to a end user, they're responsible for that machine. If I ship a crated pallet over to let's say to Germany, they unbox it, put it on their conveyor line, and now they have a palletizer machine from me. That machine breaks down or somebody gets hurt. I am responsible for the safety of that machine until end of life. So it's important to remember that it's different internationally and that you can be held accountable, and specifically engineers can be held accountable for improper design. So making sure you're following these two standards, 13849, 62061, whichever one that you follow, and you document properly what you're doing, it's very, very important. So since these were put together, I think 2011 is when 13849 became the overriding standard for safety. It replaced 954, which some of you might know as the category standard. You had to follow this if you're using anything in Europe, right? And since that time, it's come up a lot of times, is this valid for the United States? Can I follow 13849 in the United States? And the answer is kind of. So OSHA initially had said outright that no, they don't accept those standards. It's not part of what they're doing. So they won't hold them as law, and you are not required to follow them. Also, they won't be held to them. However, remember that general use clause at the beginning that I said, if international standardization bodies start reciting them, or national standardization bodies start putting it in there, then you'll have to use it. So you get, excuse me for a second here, you get to this ANSI B1126 which is the functional safety for equipment, which talks about how you use 13849 within that standard. And then you have Ansi RIA 1506 specifically for industrial robots. So they do cite 13849 directly in that standard. So if you're following this national standard, they cite 13849, therefore you must use it. So it can be kind of confusing. I understand if you're following along here, you're like, Zach, you're not making any sense. Why would they do something like this and not make it that much sense? So I can tell you, internationally, there was an attempt to harmonize two standards to make things better. That was this EN ISO 17305. That has been canceled. So there is no harmonization of these two performance level or SIL standards. So that's not happening anymore. And it really became the United States national standardization bodies started liking what they saw, 13849. It makes a lot of sense in terms of what you should be doing performance-wise. So when you talk to members of the RIA, you know, they're specifically tasked to follow certain parts of 13849, and it's brought out right into that standard, so they know what performance level needs to be met for a robot, and therefore it's helpful internationally. So there's lots of these standards being incorporated all the time. The biggest thing I can say is make sure you're following OSHA, keep digging down into national standards, and it's always important to understand the international standards. Then the one other piece I have here is the Ansi S84.01 and IEC 61508. Again, we're just focusing on machine safety today. These are specifically for process. Typically, if you're using these, you'd be in some type of, you know, oil or ethylene cracking or some larger process. You could be in food and bev. Sometimes they use these. But this is an overarching standard that is your main SIL standard. And then 62061 would be the offshoot machinery version of that. So just an FYI, if you're talking 61508, 61511, they're similar standards. They are not the same standard as each other, and they're not what we're talking about today. But I can also answer questions. It's just a whole nother presentation. So the first place people start, remember I said the first thing we have to do is figure out what type of risk we have, right? And there's lots of standards, 12100, IEC 12100, ISO 12100 can take you through a risk assessment and what you need to do. Always do that. Please, please always do that. If you're following directly 13849, they have this required performance level risk graph in here. So the lowest risk application would be a performance level A. The highest risk application would be performance level E. And it's pretty simple on how you get there. So you have severity of injury, duration or frequency within the hazardous area, and then preventability. Severity of injury is going to be, is it reversible or non-reversible? So cut, bruise, typically a reversible injury. Broken bones, loss of limb, loss of life is usually irreversible. I would classify broken bones into irreversible because depending on the break, you might not be able to reverse that. So simple question to start off is it a reversible injury or an irreversible injury? And if we're talking about, let's say it's a power press that comes down, it comes down pretty slow. It's a stamping machine for spoons. And I'm the operator. I keep my hand in there to take out the form, put the new form in, take out product. I'm in there, so therefore I could have that press stamped down on me. Typically a press going on your hand is not good, and I would say that's irreversible. For this example, we'll start at S2, right? So then frequency of exposure, are you in the hazard zone more than once a shift? As that same operator, I'm sitting here, I have the power press machine, I'm putting my hands in every cycle to take out product, put in a new form. Yes, I'm in there very often, right? So F2 we'll put for that one. And then preventability is how likely are you to notice that something is not happening right? How quickly can you remove yourself from the system? So if it's a fast moving robot, you probably wouldn't notice it until you were getting hit, and that could be very bad. For this example, I had, we were using a very slow press machine. It's very loud and noisy. So I would know when it's going, and I should be able to remove my hand because it doesn't come down quickly. So in this case, I go through all my steps, I get performance level D. And again, when you're doing this, this isn't an individual activity. I'm not sitting here by myself going through and assigning performance level requirements to all of the machines in my facility. I would have a safety team together going on site, learning about the machine, figuring out what's going on, and then assigning what different functions within that machine are at what risk levels. So I could have a machine that has multiple different risk levels depending on what I'm doing. So it's important to go in there and make sure you have a whole team doing this, not just one person. So then performance level, what is it? If you're familiar with category standard, category is design. We'll get to that in a little bit. Performance level is a probability of a dangerous failure per hour. So it can be graded from A to E. So if you take the reciprocal value, it ends up being the time until a dangerous failure happens. So for a low risk application, I can have 10 to the negative 4 or 1,000 hours until I have a problem. But remember, if I go back one slide, performance level A is going to be reversible injury, not frequent, and very preventable. So if I do have, something that happens in here, the chances of it actually causing harm are very low. I'm not there all the time, and it's extremely preventable, and I should probably be able to, get out of there. But then you look at high risk. High risk, you're talking the exact opposite. Very dangerous, very frequent, impossible to avoid. So if I'm in a sawmill and I'm constantly cutting wood, I need to make sure that I'm not miscategorizing this below performance level E, because if I'm in there and I could lose a finger and I could do it every 4 times a cycle, and I don't have any safety mechanism to stop it, I need to make sure that I get a safety mechanism that'll be very safe. And I've seen many saws that have that instant stop when it comes in contact with like flesh, or it's a lot of times they use a hot dog when they're showing it. So actions like that would definitely be down here in this high risk. And that's basically saying that you can't have a dangerous failure when it's 10 to the negative 8. So I think that's 10 million hours. So it's very important to understand what these levels mean and how you get to them, because once you've assigned a performance level, you need to then achieve that performance level. So how does that work? And for this next part, I'll make myself disappear from the screen so you can see a little bit better what I'm talking about. So performance level is going to be whatever category you assigned here. And to get to that performance level, you need to have a few things. So first, you incorporate control categories. So if you're familiar again with 954, this is the category design, single channel or redundant. You need to incorporate your component quality, and you also need to incorporate what's called diagnostic coverage from category 2. We'll get to that in a second. The last piece here, again, from category 2 is protections against common cause failures. All of these pieces here need to be implemented into your design in order to determine if you've reached the appropriate performance level for your system. And we're going to walk through that real quick. And the most important thing that I think people often get confused on is this control category. So before we go any further, control category, you'll see here in a second, is about system design, redundancy, or monitoring, or redundancy and monitoring. But it's not to be confused with stop category. So a lot of times people will talk about stop category and control category in the same way. Stop category is very different. So a stop category is either 0, 1, or 2. A stop category 0 is instantaneous removal of power. So if you can imagine, I hit an e-stop, I immediately drop power off of my my motors or contactors, right? And I remove power. Stop category 1 is going to be delayed removal of power, meaning that I hit my e-stop, I initiate some type of braking system, which could, for a large drum that spins, just removing power could be bad because it could spin for a long time. So I hit that e-stop, it initiates a brake, and then after that brake is completed, a set amount of time, it then drops power to it. And then a stop category 2 is going to be delayed stop, but there is no removal of power. And typically a category 2 is not going to be, a stop category 2 is not a safety stop. For all intents and purposes, safety stops are going to be 0 and 1 on your stop category. So a little aside there, but to add clarification into when we're talking about a stop category versus when we're talking about a control category. So let's look at single channel designs, safety categories B, 1, and 2. For all intents and purposes, category B and category 1 are lumped together. They are essentially the same design as each other, just probability is a little bit different in the old risk graph. So B and 1 are just plain single channel designs. Category 2 has a test device in between your signal to basically catch a loss in safety between the cycles. So let's look at what that looks like. So again, category B and 1, I have input going to a logic, going to an output. This could be an e-stop with one channel going to a safety relay that only has one channel of logic that's going to a single contactor. This would be a single channel design. There's only one of these. It's completely fine, right? Category 2, safety category 2 introduces this test equipment, right? So that in between a cycle, I'm going to test here to ensure that everything is working. We don't see safety category 2 very much anymore. The reasoning behind this is 13849, I believe, set the number of tests between cycles as 100. So if you're doing an e-stop and you don't use that e-stop very often, let's say the mission time on that is 20 years and you said that you're only going to use it like once a year, probably at the worst. In that case, you would need to test it 100 times in between that 1 year period in which it would be used. That's all well and good for an e-stop, but if you have a light curtain and someone's constantly breaking that light curtain to get in and do something, it means that you would have to test that light curtain 100 times in between the usage time. So if it's once a cycle, that means you have to test it 100 times in between each cycle, and it just becomes impractical. So for most intents and purposes, safety category 2 is not used in terms of design anymore. It also can be more expensive than just a standard safety design because the test equipment can be expensive as well. So if we're looking at this, I'm just showing an example here. I have an emergency stop that's tied in single channel, one normally closed contact here. It's going into one channel of logic of my relay. Even though my relay has two channels of logic, I'm only using one. I have single relay contacts internally, and it's going out to a single contactor here. So what category is achieved here? It's hard to tell without any other information, but if you just go by single channel, double channel, single channel on any part of this makes it at best a category 1. So at best, this is category 1 with no test equipment. So I would say it's either B or a 1. Probably category 1 is because you're at least using a safety relay. You know, maybe that's a little bit better. So category 1 here. So now let's look at dual channel, and this is where things got confusing in the previous standard 954. It didn't talk much about component quality or anything like that. It was only talking about this category and how you should design it. So category 3, dual channel, when a single error occurs, safety is maintained. In some, but not all errors are recognized. So multiple errors could lead to a loss in safety, but you're monitoring some of them. Category 4, when a single error occurs, safety is maintained and you're recognizing and monitoring all possible errors. This was causing a lot of problems when people were designing in the 2000s because, you know, what does all mean? Does all mean I need to know exactly what happened when it happened? Does all mean I need to protect against errors that I don't know that could occur? What does all mean when it comes to a microprocessor? Can I actually know all the errors that could happen on that? So this got to be confusing, and you can see here, I'll switch back and forth between this. Now we have input, so 2 channels of an input going into a logic device that has 2 channels. That's going out to 2 output contacts. And the difference between 3 and 4 is dotted lines are no longer dotted. Right? So now I'm monitoring everything. I have to monitor everything. I go back and forth between these. You can see there's really no difference. It's just that monitoring dotted line becomes a straight line and is required. So what does that look like on a system here? We're looking at this wiring example here. I have a light grid type 4. It's got 2 OSSD outputs. The outputs are pulsed, so I know that they're monitoring internally on that light grid. Internally here, I have 2 channels of logic that I'm going to on the safety relay. I have redundant contacts for all of my contacts going out here. I am doing redundant contactors out to my motor And then I'm also monitoring out here the normally closed contacts of my contactors to the motor. So in the best case scenario, again, without knowing much information on here, I would say I definitely am at least category 3 because I'm redundant, right? I have redundant inputs here, redundant logic, redundant contactors output, redundant on this as well. The big thing comes to monitoring. What am I doing on monitoring side? Am I getting all? And that was the hard part. Nobody really knew if all was happening. So I would say if we're looking at this, all, I know it because it's our relay and this is how we design it. Yes, you are covering all your bases here because the inputs are being monitored. It's being monitored by this receiver. Internally, we're monitoring these contacts in here to make sure that they're working properly. And then externally, we have redundant contacts on the motor that are being monitored on our start. So that if one of these were to fail, we would know that that happened and not be able to start our machine again. So again, it can be kind of confusing when it came to category and what was required. The important thing now is that it's not just category design. You actually get flexibility with your design. You can do different types of things when you're going through this. You can start at B all the way up to 4 and figure out what's right for your machine. But if it was the old 954 standard, you were basically from a risk graph right to what design you needed, and then that was the end of it. The other thing that meant is that if I'm looking at the category here, I was just with this. So previous to this 13849 standard, the only thing that mattered was redundancy or not and monitoring. Now we've added in component quality. So you could argue that in the old standard 954, I could have a system that is made with well tried and true parts from a safety manufacturer. So I have safety e-stops. I have a safety relay. I have safety contactors. All of them are certified by an external body, right? As long as the design was the same, redundancy and stuff like that, I could take those e-stops out and put a potato in there. I should say 2 potatoes because we're doing 2, and then use some type of knife mechanism to cut them apart. And because none of the requirements for component quality were actually in that old standard, they would be held in the same regard because of design and not component. So that's kind of a problem when potatoes hold the same merit as a safe e-stop. So that's why they started adding in this component quality. So this component quality is essentially a measure of mean time to failure dangerous. So it's a statistical value. It's not guaranteed service life or anything like that. And this is on the manufacturer of this would typically provide it for you. So it comes in 3 categories. There's low, medium, and high. If you're beyond 30 to 100 years, you don't get extra points. You get lumped into high. If you're below low, you just you don't have a safe component or a well-made component. So if you're below low, it's not allowed. Anything above high gets lumped into high. And so what this does is it gives you a way to basically look at different types of what we have, different categories of light curtains, different manufacturers, and to give them all an even playing field now by saying, is it independently serviced by a third party? Do I have approvals on here? Does it tell me, what classification I have? I can ask for these questions. And then if I don't, I can actually reference the 13849 appendix, figure out what type of application I'm using, and then calculate it based on my my cycle time. So it gives us lots of ways to go through and do this. It was really helpful when people had already designed components. They were sitting in the field for 954. You needed to figure out where you were. This is not so much a problem anymore, and especially with this math, not that big of a deal because many manufacturers do provide the MTTFD values for you now, and it's easily brought into the documentation. So again, here's the appendix from 13849. It gives you some idea of what you're looking at here. So mechanical and hydraulic components. You can get a basic MTTFD of 150, again, beyond the high value there. And then if you're using pneumatic components or relays with a small load, relays with a maximum load, you can get different B10D values and calculate it that way. So there's lots of opportunity to go out, figure out if something is in an existing equipment, is it satisfying the needs? If it's not, what is the requirement and how do we get there? So again, we've calculated categories. So how am I designing this? Am I redundant or not? What quality components am I using, right? Are they good quality, low quality, high quality, medium quality? And then the next part is from category 2 up. Remember I said category 3 and 4, some errors were monitored. You could catch some of them. 4 was all were monitored. Now from the appendix again, we can actually determine how well we are testing. So if we look at this, the diagnostic coverage is actually the percentage of dangerous recognized failures over the dangerous failures. So how many of them are dangerous and recognized? That's your diagnostic coverage. So the way this works is if you're below 60% diagnostic coverage, you're not doing any monitoring. Low monitoring is considered 60% to 90% diagnostic coverage. Medium is 90 and below 99. And then anything that is 99% or above is high. And a lot of these, again, are in the appendix for 13849, Appendix E. So if you're confused on what I'm talking about or you need examples, you can go directly to the appendix there. And I'll show you what we're talking about. Here's just a few examples. So if I'm using a cyclic test by change of input signal on a sensor, that's 90%. So it'd be categorized as your medium, right? Logic, so simple time monitoring, Watchdog timer, that's only 60%. So if you were using a Watchdog time before, you need to realize that you're at a low diagnostic coverage on that. If that's the only thing that you're doing. If you're doing an actuator, so direct monitoring by supervision, if you're using a plausibility check by positively driven or force guided relays, both of those are 99%. So it's really giving you a way to look at statistically how well am I monitoring things and getting away from that sum and all. That is very confusing. So we've gone over, again, what's the design look like? What type of components are we using? And then how good is our diagnostics of what we're monitoring? Finally, the last piece here is if you're following this 13849 standard, which a lot of the national standardization bodies are moving to, is how do I do this common cause failures? Like, what does this mean? And so the way that a common cause failure works is it's a list of various different things. There are failures that can cause a failure on both channels, even though it only happens on one. So again, this is from an Appendix F in the standard. You can go through and look this up, and what you need to do is achieve 65 points. So if I'm going through and I'm talking about my safety function, I'm using separated signal paths, I have diversification, protecting against EMC right there on that. So that's 45, 50, 60. So I just need 5 more. So I'll be making sure that the training and maintenance, training for my developers and maintenance, they understand what common cause failures are. I've reached 65. So essentially, the standard is pushing you to do things that is good for your system, well tried and true methods within protection here, and making sure that you're also training your people within your system to make sure that they know what they're doing. So that one's just a chart. You go through and do it. And when you're done, I know this is crazy. We've gone through all these steps. Now I can determine what I need to do or what I'm doing doesn't meet what my requirement is. So that gets me to this graph. This graph is red. Basically, I do my risk graph at the beginning. And let's say I came up, I needed performance level C based on the risk assessment I did. I need performance level C. Well, now I have multiple ways in which I can design, right? I can use different categories. So I can do single channel all the way up to double channel, and I can use different quality types of components to achieve that. Whereas before, I was just given a relationship between category build and risk. Now I have options. So I need to get to performance level C, right? Here's my required performance level. Now I see different ways I can achieve this. I can achieve this by doing a single channel design, category 1, right? And I can use high quality components. I can achieve performance level C now with a single channel design, which is better because in the risk graph in 954, I almost couldn't get that risk area on a single channel design. But if I'm using, let's say, okay, I have an existing thing in place. I don't have access to high quality components, or I didn't. Now what I could do is I could say, all right, well, I'll do redundant design, right? And maybe I'll save a little bit of money on my components by using something with an MTTFD of medium, because now I don't need the best thing ever because I'm using redundancy and I can still fit in here. So it's a way of looking at design mixed with component quality. And the big thing is now when I get into redundancy, I can say, okay, I only have to do low DC average for this one. And if you recall, before I was saying a Watchdog timer was low. So I could still use that design and achieve this for my system. The best news out of all of this, there's free software out there that you can use that'll help you basically create the documentation and walk through this on your own. It's called Systema. It's created by a German Professional Institute for Safety at Work. It is extremely easy to use. It walks you through all of these steps, and it generates all of the paperwork required for this. So if you're going to ship to internationally, I guarantee you they're going to ask for this documentation to come along with it. So you can use this platform to create that documentation, create the things you need for it. If you're shipping here within the US and you're, say, doing a robot system, I guarantee you the RIA and the standardization bodies would be real happy to say that you have provided a Systema sheet, and you'd be really confident when you deliver that product to the customer saying, yes, this is a machine, this is a guided robot, I'm following these standards, here's what I used to do it, here's your documentation, congratulations, you now have a safe robot. So there's different ways to get around it. There's different ways to go through this. I know it seemed like a lot when we were going through it, but it's important to make sure you know, first of all, what your customer is asking for in the United States. What are the requirements of their system? Are they driving those requirements? Is it a requirement driven by specification? Is it a requirement driven by standardization? What is the need? And if they don't know the answer to that question, the last question I would ask is, okay, what is the need of your system? Why are you doing this, and why have you spec'd in something safety? What can I do to help you? I want to make sure that we get this way. And a lot of people sometimes, I believe this is my last slide, yeah. So a lot of people sometimes, and I'll just leave this up and I'll answer the questions that I have here in a minute. I get a lot of questions of, well, if I don't search for safety, it's not a requirement, right? The second I start looking at my safety system, that's when I find that I did something wrong, and then I'm obligated to do it, right? Ignorance of the law doesn't mean that you're not held accountable by the law. So if you're not looking for it and you haven't done it, just because you're ignorant doesn't mean that you don't need to do it, right? It just means you haven't found it out yet. In a lot of cases, we'll go through, and I've talked with customers that have been doing things the wrong way, and they've, the one thing we didn't talk about is if you send it off to a customer and the owner is responsible, great, they get fined, I'm not worried about it. You also have to look at civil, the civil court system here in the United States as well. If someone is hurt, or the representatives of a family of someone that died may be looking to find lawsuits or ways around to hold those accountable, responsible for it. Everything we've been talking about up to now has been requirements by law per Osha and requirements beyond what they say is needed. If you go to a court of law for civil, you're going to have to prove you did your due diligence. And I've talked to manufacturers of all different types of conveyor systems, saws, and a lot of them are proud that they've defended themselves. But it can be very costly to defend yourself especially if you've not done your due diligence on your safety system. So the best thing you can do here in the United States is, 1, follow OSHA guidelines. 2, ensure that you know what your customer is asking for, and you get it in writing if they are asking for something in safety and they make references to a specific standard. And then 3, whatever standardization is required, you follow that and then generate documentation based on it. So if they're asking for an old standard and that's what they want, make sure you provide that, because they have asked for it, that's what they're doing, whether that's right or not. So it can be very confusing here in the US. And at times it feels like sometimes we're working against ourselves to get this stuff working. So All right, before we wrap up here, there's 2 questions in the chat. So let me read those right now. Great presentation. Thank you very much. When you said shipping international and, oh, this is a confusing. If you said international shipping to Europe, is there a way I can find Brexit information? Okay, so that's a very good question. I would defer to my counterparts in the UK. I haven't read up on Brexit that well, especially when it comes to machine standards. I know that in general they've held most everything the same initially, and then they're going to look at things moving forward, and that's just across the board for the Brexit thing. So I apologize, I can't answer that question, but I would direct you to the team in the UK for Phoenix Contact. Tony Dean's a good person to talk to there, and figuring out what's required in the UK. All right, one more here. Yeah, can I get more information on these? Is there a good place to? Okay, yeah. So internally for Phoenix Contact, we do have a website. I can put it in here. Let me make so that's www.phoenixcontact.com/fit4safety. So that link will take you directly to an information page where we have a lot of information discussing requirements and standards and definitions and lots of different things. I would also recommend, if you have a local safety integrator, contacting them. There's a lot of people that do safety directly here and focus on end user safety requirements. Definitely check them out. If you have questions, they'll definitely be willing to help you get yourself safe. Okay, I don't see any other questions in here. I appreciate everybody's time. Thank you very much for staying on with me. Hopefully you found this information useful. If you have any questions, again, my name is Zachary Stank, zstank@phoenixcontact.com. Be glad to help you with any further questions that you might have, get you in contact with people in your region. And also, just remember phoenixcontact.com/US-webinars. I'll put that in here right now. All of these are recorded, so shortly after this one is done, if you have a colleague that would like the information that was put in here, you can just send them back to that page. The live replays are linked directly from that. There's no sign up for that one. So you can just go back and replay this. You can show it to your customers. You can show it to your colleagues. I mean, you can show it to your dog, but I don't know if your dog would like it. But yeah, all of these are there for you to watch. We'll have more coming up at the end of this year. And if you have any interest or things you'd like us to cover, please don't hesitate to send me an email, and we can do that as well. So thank you all again very much. I appreciate you being online with me today, and hope you have a safe rest of the day. Thank you.